Now, listen, today we'll be discussing a very important thing that sometimes bothers students, which is number of significant figures. Which figures are significant and which figures are not significant? Significant figures. Now, first thing that you have to understand that is name is misleading. It seems like significant figures mean figures or numbers that are important. It is very confusing for some students. So let's put that confusion to an end. So what is meant by significant figures? If it is not important figures, then what figures are significant figures? Significance in this case means assurance of of the value of a digit. Like how assured you are. For example, if somebody measures the length of a table, which is 1.234 meters. So I hope you will agree with me that he will be 100% sure that this number is confirmed. So I think you will not think that that person can get this number wrong. Then these are decimeters. Again, there is less chance of this to be wrong, but obviously more than the whole meters. Now these are centimeters and this is millimeter. So this one is most significant and this 4 is least significant. So significance is a comparison between the numbers. Assurance, how assured you are, how confirm you are about the value of a number. Well, why I say that third, like 4 is the least significant number. Now, actual size of the table can be 1.2335 to 1.2345. So actual length can be more than or equals to or less than this. So all these numbers, they will round off to 1.234 meter. So that means this 4 is not, is something that we are not 100% sure of whether it is there or not. So what numbers are significant and what numbers are not significant? Here is a list of rules. Rules for significant figures. Remember, significant figures are not, they don't depend on calculations. They actually depend on the measurements. What instrument you use. Excuse me. What is the technique you are measuring something? So significant figures are controlled by the measuring techniques, not the calculations. So number one, all non-zero digits are significant. 1, 2, 3, 4, 3.124, 31.42. They all have 4 significant figures. Now, second is, excuse me for the coughing. Now, the question is always about zeros. Zeros are may or may not be significant. Let's see which zeros are significant and which zeros are not significant. All zeros between two significant figures are significant. What do I mean by this? Like 1, 0, 0, 1. 2.004, 0.3041, all have 4 significant figures. Okay, now excuse me. Zeros on the right end of value after decimal are significant, like 0.3000. Now, this is where the math students, they don't buy that, because math students think that 0.3 is same as 0.3000. So they think that these zeros are not important. So how come they are significant? So I remind you, in the beginning, I told you significant did not mean important. It means how did you measure, how accurately you measured something. For example, 0.3 can be any number between 0.25 and 0.35. whereas 0.300 can be any number between 0.29995 to 0.30005. So you will find that this number is less accurate and this number is more accurate. So this is the way of comparing the significant figures. Sometimes students think that significant means important. It is not necessary that zeros that are significant, they are important, because they are not important for calculation. But when a physics student sees 0.3000, he knows that some very accurate measurements are taken. So confirm that this 3 and this is 0 and 0. So this makes the value more reliable. So now one more example, 21.20 144.0 all have 4 significant figures. Now, zeros on the left before non-zero after decimal are not significant. Now, this is where the math students again uh, they they start rolling up their sleeves and they want to have a fight on this one. But again, you have to understand that significant does not mean important. For example, somebody says 0.00030 has 2 sig fig. Then math student says these zeros are actually making making these 3 very, very small. They are very important. Yes, they are very important, but they are not significant. Whatever instrument you used, it started to measure something from here and ended up over here. So this is the most significant digit, and this is least significant digit, and they are not significant. Zero point zero 1 1 0.030 0.0000025 all have only 2 significant figures. Okay. Significant figures are different from decimal places. Zeros on the right hand of a whole number are not significant. What do I mean by this? Listen, 23,000 140 2200 79 million all have only two significant figures. So remember, the zeros on the right hand for the whole numbers are not significant. For example, the last digit was actually, when it showed on a calculator, this was 7895310. Okay, so you decided it to round off over this point. So the next number is more than 5. So what you do, if you're rounding off at 8 and the next number is more than 5, you're supposed to increase 8 by 1. It will become 79, and you will replace all the other digits with zeros. So this is how we round off whole numbers. You don't need to put zeros when you round off a decimal number, but when you are rounding off a whole number, then whatever numbers you are ignoring, you have to replace them with zeros. And those zeros are not significant. Those zeros are what? Not significant. So this is a little bit of a revision for significant figures. Students normally find them very, very difficult. Sometimes confusing, not difficult. Sometimes they find them confusing. So if there is any issue, you can raise hands. Okay. Now, rounding of a value and its uncertainty. Now, what do I mean by this thing is, rounding of a value and its uncertainty. For example, you get a value like 13.47943 plus minus its uncertainty is 0.28734. This is raw answer from calculator. So your calculator gave you this answer. You have to properly round it off. Now, what is the technique? Let's start from the error part or uncertainty part. Rule is uncertainty should have, and we are talking about absolute uncertainty. It should have only one significant figure. So let's see if you can round off this number to one significant figure. What will be this number if I round it off to one significant figure?
0.3.
What do you think, Subhan? Sahil?
Yes, sir.
What do you think? What will be this number that I'm talking about the uncertainty if I round it off to one significant figure?
Sir, 0.3.
Good, good. So it will be 0.3. Now, uncertainty is 0.3. And it has only one significant figure. Look at the position of that one significant figure. And in your mind, this is what you can do. In your mind, not practically over there, just put this decimal under the decimal and see what number corresponds with the only one significant figure in your uncertainty now. Which number is against the single significant figure? So you will find that it is 4. So this is where you have to round off the quantity. So what should be your final answer now? If I round off 13.47943 at the first 4, the next number from on the right hand side of the 4 is more than 5. Sure, I should get 13.5 plus minus 0.3. So this will be your final answer in the proper number of significant figures. Okay.
Yes, sir.
One more example. 79384.347 plus minus 5495.3.21. How will I round it off to the proper number of same figures? This is the raw answer. What should be my final answer for this one? Listen, now I'm dealing with a number. When I will round it off to one significant figure, it will be in a round figures. So I have to round it off to this number. It will become, because the next number is more than 5, so it will become one more, that is 5. And I have to replace the numbers before decimal with zeros. So this should be my error. Now, when I compare this here with decimal going under the decimal, I hope you understand that if it is a whole number, the decimal is at the end. So my only significant figure is corresponding with 3. So what should be my final answer now? I have to round off at this point. So 7, 9, the
4.
come forward, it should stay 3. Good. Then, because
0.
it is again a whole number, I have to replace the digits that I'm ignoring with zeros and plus and minus. So this will be the final answer. Let's see. Okay. Let's see if anyone can round off this one to the proper number of same figures. I'm ending the recording here.